So we'll make this video available on request. Right. So very good morning again. So this is the HPC user training that many people have been waiting for a very long time. Sorry, and well, finally we got some time to have this discussion. It's always good to have these things in person, so that particular questions can be asked that you may have been facing. So this training is meant for the HPC users of IIT Mandi. So this training will be particularly tailored towards the hardware we have, which we call the HPC cluster at IIT Mandi. Okay, the audience for this training, mostly this is targeted towards people who are going to start using the HPC. But if you have been using it and you have been facing issues, probably some of your queries could be addressed during this discussion. But this training is not for addressing particular queries that you have faced recently. So this is not a troubleshooting session, although we will have a session on how to troubleshoot certain common problems that we have. But this is not to help you solve your particular research problem and so on. Right. So we have 20 people. Good to see them. Just through the chat, can you please mention uh, just mention what is your field of work? So you could mention chemistry, physics, molecular dynamics, engineering, CFD, whatever it is, just to get some sort of idea as to what the audience distribution is about. Yeah, just type it. So we've got computer science, biology, mathematics, physics, applied mathematics, molecular dynamics. You can also mention what sort of software you use, what sort of research tool you have been using. I just need to see words on the chat window so that MATLAB, yes, good. Gaussian, ANSYS, very good. WASP code for material science. Okay, that's the first time I've heard of it, but good. Quantum espresso, right? Python, yes. So very good. So we see a very wide spectrum of users of HPC, which is what we want. We want this community to be very heterogeneous in the sense of um, types of applications as well as software. Okay. So before I move on, is there anyone who has any particular questions, requests, anything? So this meeting is being recorded. So if you have any issues with you appearing on the meeting, keep your videos off. If you would want to ask something and not let that appear on the meeting, then ask it towards the very end when we have switched off the recording. We're recording this so that this can be uploaded on the HPC website. Although this will be available only on request, because we want to encourage people participating here, which makes it more fun. Anyways, okay, this is going to be very informal. Okay, there's no formality here. So if you want to use any other language than English to convey the ideas, communicate effectively, that is completely fine. Okay. This is not a regular course, graded course of IIT Mandi. All right. My name is Gaurav Bhutani. I am the coordinator of the HPC facility at IIT Mandi, and I also work in the School of Engineering as a mechanical engineer, working in applications related to fluid mechanics. So I've been managing the HPC cluster for a few years now. So I understand the hardware as well as the software. Uh, Actively work on updating the cluster and so on. Basically, it's me and Prasant Jose who have been managing the cluster. There's no dedicated administrator who manages the hardware and software. So that is the reason you may have seen that the emails reach directly to us when you send them to hpc@iitmandi.ac.in. Right. So let's move on. So here's a brief agenda of today's discussion. So we want to have 2 good hours of discussion before lunch. Lunch will happen at 1 o'clock. So we'll start with introduction to HPC. So what is HPC? This is revision, getting warmed up with this discussion. Then we'll have a 1 hour session on Linux essentials. Again, this may be very rudimentary for people who already know these things, but we'll go into certain advanced ideas such as bash scripting as well if time permits. But this is mainly to let new users get comfortable with the environment, because many people come with only Windows background. Then towards the last 30 minutes before lunch, we'll talk about writing and executing PBS scripts, that is how to submit jobs to an HPC cluster. After lunch, we'll have a 30 minutes discussion on troubleshooting. So I've come up with some standard issues people have been facing in the last many years. So we'll discuss those issues. I try to create some troubles in the code, and then try to address them to make it more organic, the discussion. Then we'll have a 30 minutes discussion on installation of software. That's very important, because nowadays we don't take requests for installing new software, because it's become very easy for you to do it yourself. So I'll do a hands-on exercise for you to show you that it's very easy and you can do it yourself. So I'll install one software on the HPC cluster here in this discussion. There was a discussion plan on virtual environment, but now it will not be happening. I'll modify the presentation. Then we'll briefly talk about certain advanced ideas if you would really want to get into a cluster and using it in a very, very effective way. Then you could read about those ideas, learn about them in your own time. We'll try to have a virtual tour of the HPC facility. So I'll ask one of our helpers to take a camera and give you a virtual tour of what the hardware looks like and what sort of place is the HPC currently housed in. And finally, towards the end, based on the distribution we have here, we will create some expert groups and give you a forum for you to interact with each other and discuss issues so that you can solve it quickly. Right. What is HPC? Okay, so HPC is, as definition, we most of us know, because that's the reason we are here. But let's formally explain what it means when we say HPC. So HPC stands for high performance computing. So HPC is used for heavy duty computing on clusters, or sometimes we call them supercomputers, which have lots and lots of computing cores. So one core can be thought of one processing, weakly saying it's a processor that is solving some computation for you. But when we start going from our local machines or desktops to HPC clusters, we would want to have algorithms that can scale up to that can parallelize our work and scale up to hundreds or thousands of cores. Okay, just to give you a perspective, on the right hand side, I've put a picture of the fastest supercomputer that we have as of today. It's called supercomputer Fugaku. It's housed in Japan, Riken. It has, let's start with the power usage. It uses a total of 30 megawatts of electrical power to run this cluster. So that's tremendous amount of power that's only required. It's like a small power plant just being used for running this cluster. It has a total of 7.6 million cores. Again, just to bring things in perspective, your laptops typically will have 4 cores nowadays. If you've got lots of money, then you can probably buy octa-core processors in laptops. But typically, we end up buying a 4-core processor in a laptop. And the computing power, which is calculated in terms of floating point operations per second, okay, flops as we call it. It's basically how many floating point let's say how many additions can the supercomputer do in a given second. So this can do a total of 0.5 exaflops. Okay. So exaflop is 10 to the 18 floating point operations. It can do 0.5 into 10 to the power 18 floating point operations per second. That's a lot. Okay. If you're more interested in that, you can go to this website called top500.org. It gives you updated lists every 3 months of the top 500 supercomputers in the world. Again, coming to the perspective of what's the fastest supercomputer we have in India, it's called Param Siddhi AI. It's housed in CDAC, Pune. It has a total of 210 AI petaflops per second. Okay, AI in the sense of some particular application. So it scales at 210 petaflops. So 1000 petaflops is 1 exaflop. Right. Now, further coming to perspective of IIT Mandi, so the current HPC that we have has a total of 50 teraflops, which is 1 petaflop is 1000 teraflops. So we have a total computing power of 50 teraflops. But by the way, there's a new supercomputer that's coming up at IIT Mandi that should be functional in a couple of months from now. That will be 650 teraflops. So that's much bigger than what we have right now. So if you're using in the cluster nowadays or in the past, it's the 50 teraflop cluster that you have been using. But the new one that's coming up, it's going to be an internationally recognized cluster. It's called Param Himalaya. Right. Moore's law, yes. I mean, this was Gordon Moore from Intel. He came up with this prediction statistically that every 18 months the computing power becomes double. Okay, that was in terms of the number of transistors you can fit on a semiconductor, but very soon that changed because the heat production became an issue. If you put too many heat producing units on a given millimeter square, then it becomes difficult to manage the temperature because of the heat density, the power density. So what happened was after that rather than trying to solve, I mean, rather than having higher overall speed of the single processing core, people started expanding modifying their algorithms in such a way so that you can split the work into multiple cores and still work with a lesser clock speed, which then allows us to manage the heat production issues. This may not be too interesting for the people who don't care about these things, but it's good to know about it, because every 18 months approximately the number of computing cores becomes double, or in a way you can say that in the same cost you can buy double the number of cores. I mean, what that means is that you should constantly keep evolving your algorithm. If you can solve a problem today on 100 cores in a given amount of money, so to say, then in 18 months you'll be able to double the number of cores and then solve the problem in the same amount of money. So the resources grow with time, as you already know in computing. Right. So it's not just the number of cores that have been doubling with time. It's also the computational methods that are evolving. So for the people who work in applied mathematics, they may already know that the algorithms that are used to solve linear equations have evolved over time. And now we have parallel multigrid algorithms which can solve linear systems or invert linear systems, so to say, using iterative methods very, very quickly. Okay. So if you're working with the code, you use some sort of linear algebra solver, do revisit it after a few years, because there may be a better method that's available that can solve the problem faster, but given the same amount of resources. But HPC is all about having more number of resources and solving a given problem. So before you start using the HPC, you have to address certain issues, you have to answer certain questions, because HPC, if used without giving any thought, it may end up just not helping you at all, or it may even make things worse for you. Okay, so let's anybody who uses HPC should know about this thing called Amdahl's law. Sorry. So let's think of this more practically. So let's say you have you have written a code, or you have downloaded some program from the internet that solves a problem on your local laptop, which is a serial problem. So just using one core, you solve it in 10 hours. Okay, and now you want to bring it to the HPC and run it on 20 cores in parallel. the problem can be parallelized. So you run it on the HPC on 20 cores, so you expect the problem to take 20 times, run 20 times faster. So that means if it's taking 10 hours, then you would expect it to finish in half an hour if you use 20 cores on the HPC. But you try that and it doesn't happen. I mean, what it does is it takes 5 hours, and you keep increasing the number of cores from 20 to 30, 40, and so on. It just stays at 5 hours or even increases beyond that, starts increasing to 6 hours, 7 hours, and as you increase the number of cores, it touches 10 hours again and even crosses that. So you get frustrated as to, and you send an email to the HPC administrator saying that please figure out what's happening. But before that, have you even figured out what the algorithm is doing? Okay, so if you've written your own code, then typically a code will have a serial part, that is the steps that have to be followed one after the other. If you're adding 10 numbers, then you can parallelize it. You can add two numbers, and then add all of them together. But if you are having time based problem solving, where the result of the next iteration or time depends on the previous one, then you can't parallelize it. You can't solve 10 seconds, first 10 seconds and then the last 10 seconds at the same time. Okay, so that problem is inherently serial. So we split the problem into a serial part and a parallel part. It's only the parallel part that you can reduce the time for. So for the serial part, there's nothing that can be done. So if you have a 10-hour problem on the laptop, 50% of which of the algorithm is serial. So what that means is 5 of those hours will have to be spent no matter what. You can't reduce that. It's the remaining 5 hours of the parallelizable part that you can reduce. So if you use 2 cores, then those 5 parallel hours will become 2.5. If you use 5 cores, those 5 parallel hours will become 1 hour. But these 5 hours of serial job cannot be reduced. Because Amdahl's law simply tells us that what's the maximum speed up you can get theoretically. It's theoretical because practically there has to be some amount of overhead involved with parallel computation as well. So it tells you that theoretically what's the maximum speed up you can attain. Okay, so this is something that has to be kept in mind before you start using the HPC clusters. Is your algorithm?
Soumya has not CC'd the file to me.
In next 1 minute, I will close this
Sorry,
meeting.
can we
So
please
I will
stay
have
on
to
mute?
join the timer.
Right, sorry for that. Okay, so this was Amdahl's law, and when you figure out that, let's say, a code is 10% serial and 90% parallel, then for this 10-hour job, what that means is the maximum speed up you can attain is 10 times, in the sense that those 10 hours can be reduced to 1 hour, not below that, because that 1 hour is a serial part that has to be done one after the other. Uh, Right, and you can actually try to do this on a laptop. So if you have a code that you can parallelize, then you try to run it on the laptop, because nowadays you'll have typically 4-core laptops easily available. So you run it on a serial job, and then see what's the time you need for running a given size of a problem. So when I say size of a problem, that could be the number of n in the problem. It could be number of cells, number of molecules, and so on. So you fix that and you solve it on a serial single processor and note the time, and then you make the number of cores double. I keep using processor and core interchangeably, but for now, let's allow that. But later we'll clearly define what is the difference. So if I double the number of cores and then now I run the problem the same size again, I find the time, the wall time, the time computer takes to run, and then I plot it. So on the x-axis, I plot the number of cores from 1 to 4, and on the y-axis, I plot the time. So I should typically see that as I increase the number of cores, the time should go down. Okay, that's called scaling. Everybody should be expected to do a scaling graph for their software program code that they've written, anything, so that you have confidence that on the HPC things will work. Right. Let's quickly talk about. I'm not asking that. Any questions till now? Right. So if there's any question, please, as soon as I change the slide, you can stop me. and I'll be happy to address them. Right, so topology of HPC, what typically happens in an HPC, how are things placed? So we have something called a head node or a master node. Uh, that is the node that you log into, and that is the node that is connected for IIT Mandi cluster. It's connected to the IIT Mandi intranet. So when you log into 10.8.1.19, that basically is logging to the head node here. We have an internal switch that is connected to all the nodes. So it's connected to the head node as well as compute nodes. So compute nodes are particularly designed for heavy computation, whereas head node is particularly designed for lots of people to connect to it, transfer files, and so on. Okay. So if you run a computation on head node, firstly, it's not allowed. We will disable your account. Because that's not allowed. But secondly, it will take longer because it's not tailored for computations. Right. So we have lots of compute nodes which have their own name internally, N1, N2, N3, and so on. So when you log into the cluster, it's to the head node. But when you want to send a job for running, that is done through a script that we'll discuss towards the end of today's pre-lunch session. The job will be sent to one of these compute nodes by a scheduler that figures out things automatically and sends the job. So this is a typical topology of the cluster we have. So all you do is you interact with the head node, nothing else. Okay? Don't worry about anything else here. Yes, we have a question.
Yes, sir.
Okay,
So I want to ask, sir, if on head node, like we use very small code, like I want to sum or take average of some data. So can we use small codes on head node? Very minimal codes.
your voice is breaking up. Can you say that again, please?
Okay, sir. Okay, sir. Okay, like there is a data and I want to calculate a average or some sum or some kind of slope or something. So can we use those kind of codes on head node? Which
No,
takes on or
no computation is allowed on the head node. So if you have a
okay,
very small job, then you do it on your local machine, right?
okay, sir.
So HPC is used for high performance computing. So low performance computing should typically be done on your local machine, desktop, laptop, whatever it is. If you really
Okay,
want to do something, then I mean you use a compute node. So we allow serial jobs as well. So if a compute node has a total of 24 cores available, we allow people to use one of those for their serial jobs. I want to run 24 MATLAB codes, but I only have one laptop. So although I want to run them serially, I don't want to utilize the parallel architecture of the HPC, but I do want to run lots of them. So then I use the serial queue that we'll discuss on the HPC. But under no circumstances use the head node, because if you do even your small job and somebody else does their small job, lots of small jobs add to a big job, and then ultimately that crashes the head node. So what will happen is that nobody will be able to access anything on the cluster. Okay. So there are, I mean, we can put strong user access that creates lots of issues with other things as well. So we are not doing that. So there are ways for your account to get disabled automatically if you try to run something, but that can have some false negatives as well, and then that becomes a management issue. So please use the cluster ethically and do not run small jobs. It's very easy to use scripting, PBS scripting for computation. Good. Thanks for the question. Any other questions? Right, moving on. So as I said, Egg node is suited for login and scheduling jobs, not for computation, whereas compute nodes are suited for heavy computation. So typically, compute nodes will have two processors per node. Node is a physical machine, a big desktop kind of a thing, which is stationed. Lots of them are stationed in a rack. Each processor, so typically a compute node will have two processors, and each processor will have up to 12 cores. Okay, so in total, one node will have up to 24 cores available for you to run jobs. Again, the RAM will be high, so it will have of the order of 64 plus gigabytes of RAM. So some of them will have 128, some will have higher, but again, you don't need to worry about that. You just specify what resource you need into the scheduling script that we'll discuss later, and automatically the job will go to the compute node which has the resources available that you require. Okay, it will also have some local storage, so that if you are running a compute job, then the results will get stored locally, and then when the job is complete, it will transfer those results locally from that compute node to the working directory, which is a parallel file system on some other computer. But again, you don't need to worry about it. That happens in the background. Right. Let's briefly talk about parallelization. So once you have decided that yes, you would want to use the HPC cluster, then there are different ways to use it. The first one is shared memory parallelism. So typically you'll see that your code, if you have downloaded it from somewhere, an open source code, it will say OpenMP. So you parallelize it, this has been parallelized using OpenMP. So what that means is that it's a shared memory parallelism. So if you take one processor which has 12 cores, then all these cores will have access to the same physical memory. So if you have a RAM of 64 gigabytes, then all these 12 cores will have access to all parts of the RAM. So if you're writing your own code, then you have to worry about these things. If you are downloading a code, then nothing to worry about. But just remember that if you are using OpenMP for parallelization, then it can typically only be used to solve small scale problems, because you cannot go beyond 24. So one node which has two processors will have access to the same memory. So not more than 24 cores. If you go to beyond 24 cores, then that is not shared memory parallelism. So things will start misbehaving in that sense, or it will just crash. Okay, the other type is called distributed memory, which is I mean, you have multiple nodes that are running the same job, multiple physical nodes. So each node will have its own memory structure. So two nodes which are physically separated from each other will not have a common memory. So they will only communicate through a cable that's connected between them and the switch. So if I go back, you can see these cables being connected. I hope my mouse is visible.
Yes, sir.
Okay, thanks. Right. So the compute nodes will talk to each other through the switch. Okay. So the communication becomes much slower. In fact, typically you use a 100G gigabit connection, but we don't have that as of now. We only have a 10 gigabit connection. So we don't allow distributed memory parallelism till now. So codes which are parallelized using MPI, if you run them on 24 cores, they will typically run as a job which is like an OpenMP job on a single node. But if you go beyond 24, then things will start becoming slow. But that is only until the next few months. But after that, once we have Param Himalaya functional, then you'll be able to run MPI jobs, which are much larger in size. Okay, so for the molecular dynamics people, this is a good news. Right. If you want to write your own code, then writing MPI based codes are take more time. They require a much complex algorithm, because you have to figure out how to send what information to be shared and when to be shared between different nodes. So it's a bit more complicated. Finally, it's the third one is GPU based parallelism, and that's getting very popular nowadays, because if you have it's suited for jobs which are very similar in nature and have to be parallelized. So let's say adding two numbers and doing this for thousands of numbers, a pair of numbers. So very simple jobs, but highly parallelizable, and this can be done using GPUs. So some jobs such as matrices and all, which are actually physically structured in the same way as you have a graphics card, which was actually designed in that way so that you can deal with pixels on the screen. So GPU cores can become very useful. Okay, so we have in fact a cluster which is dedicatedly called a GPU HPC 108.120, which has nodes which have one or two GPU cards, good quality NVIDIA GPU cards. So people who use AI, machine learning, image processing, they will end up using those GPU clusters. Okay, so you have to make a decision as to what sort of parallelism you need before you start writing a code or downloading something from the internet. Right? Any questions on types of parallelism? Right. So let's talk about the website of IIT Mandi, HPC IIT Mandi. So most of you would have seen it if you have an account on the HPC cluster. But let's quickly, let's talk about it first, then we'll browse through it. So this is the link to the website. You can also access it through inside. There's a link there. So we have two clusters. One is called CPU based cluster. It's called CPU HPC. This is the IP of the cluster to log into it. The other is GPU HPC, which is a GPU based cluster. Both of them share the same file system. Same file system. They share the same NIS server. So you can log in to any one of those with the same credentials that are given to you on the HPC cluster. And again, if you change a file here, then that is reflected in here as well, because the file system is the same that's mounted on both of them. And there's a 10G connectivity between the nodes. So the information can transfer to a maximum speed of 10 gigabits per second. There are two file systems available. One is called home. That is the one that you log into as soon as you, that is the one that you reach as soon as you log into the cluster. There's a limit of 10 gigabytes of storage allowed on the home. So home is typically for you to store your Python scripts and codes. It's typically much faster. If you want to transfer scripts and access them from there, they are there on home. There's another one called working directory, which is a parallel file system on the cluster. It's slightly slower, but it has much more size available for storage. It's a 2 terabyte of storage allowed on the working directory. So if you are generating lots of big files, then you would typically send them to the working directory, because if your home exceeds 10 gigabytes, then your account stops functioning. And the same happens for working directory as well. Right, software. So some basic software is installed. Nowadays, it's mostly the we only update certain libraries which are very fundamental in nature, and we also have something called Singularity Container installed. So that allows you to install your own software, any software you want, and run it on the HPC cluster that we'll talk about after lunch. It has, the website talks about the software available on the cluster. Then the website has some sample PBS scripts, that is how to submit jobs. So it will have some sample scripts so that you can start with the one that is the closest to your application and then modify it. It has queue details. So for sending the job, you have to decide which queue to send it to. So queues are mapped to physical nodes, computing nodes. So depending on your access to a certain queue, you can choose which one is the best. And then, so those details are updated on the website as well. And we have certain resources available so that you can improve your understanding of the cluster. Right. So let's have a quick tour of the website. Right. So this is the HPC website that will come up soon on your screen. Okay, so there's a home page which talks about the cluster, some notices, some critical notices. If you want to have a new account, then you can go to new account, click this Google form, fill it. It automatically generates the process flow that starts the account creation process. First, it goes to your supervisor, then it comes to us, then we create an account, and automatically an email gets generated and sent to you. It has some information about how to log into the cluster, how to access the cluster. It talks about file systems. Then there's a tab for software on the top. It talks about some basic compilers available, some software, and then we'll keep updating it with types of applications once I get information from what are the typical users of HPC that are interested in this discussion. There may be many other users who already are comfortable with the environment because of the discussion that happens regularly in their research group. So those information we don't need to update here because they already are comfortable with that to the group discussions. It talks about submitting jobs. So if you have a script available, then how do you submit that script? So using qsub command, then how do you figure out what sort of queues are available? How do you delete a job if you have sent it? You no longer need to run it, and so on. It has useful scripts, as I mentioned. So it takes some time to load. So we have these files uploaded, which has some certain different types of queues. So for open MPI, MPI kind of scripts, we have some further MPI CH library based scripts, OMP OpenMP based script. Then we have CUDA for the GPU people. Then we have a Gaussian script here, and so on. List of queues, as I mentioned, so that's they're also available. So please develop the habit of reading this, because as an HPC user, one has to get comfortable with understanding these things. Only then the user experience is enjoyable on the HPC. Right. Some information on the nodes and so on. So there are lots of stuff available. If you're interested, you can go through it. And at the bottom of every page there is a link to join mailing list. So there's a mailing list available for the HPC. Not sure if that's updated. Right, it takes some time, right? So this is the mailing list. It's basically a Google group called HPC users. So all the notifications about the HPC cluster updates and so on are sent on the mailing list. Nowadays, earlier we used to enroll people as soon as they create accounts, but nowadays we have left it to the people. So you can go to the website and join this HPC users group yourself on Google Groups, through IIT Mandi account. So then once you join this mailing list, then you can actually interact with each other about stuff, or also, but nowadays, I mean, for the past, it has mostly been used for notices from us. But feel free to discuss amongst each other using this mailing list or Google group as well. And it's highly encouraged that you interact with each other, because I mean, believe me, that's faster than you waiting for me to reply, because I have lots of other things on my plate as well. So if I figure out that issue is not critical, that does not affect others, it's only a problem with your understanding of the cluster, I will mostly not reply to it, because that's not in the scope of HPC. I might certainly sometimes do it if I'm feeling extra enthusiastic, but again, the replies will be very terse and just specific to how you can address those issues by yourself. Okay, so mailing list can help you interact with each other as well. Any questions?
Hello.
Yes, Venkat.
Good afternoon, sir. Actually, I wanted to ask the question about the softwares that you have mentioned that are installed there or can be installed later. So how can we access those softwares? Like if it's for the scripts, as you have told that different kinds of codes are to be selected. So how do we implement the same for those simulation softwares we use? Is it like running the same on the cluster, or is there any different process for the same?
We'll go through it. So when we talk about job schedulers, we'll talk in detail about how to access those software and how to run jobs on the cluster.
Sure, sir.
Okay. Any other questions? Right. So let's move on. Right. So typical problems that are solved using the HPC. So it could be lots of serial jobs, as I discussed earlier, lots of MATLAB codes you might want to run, or your own serial codes. You can do that. Computational fluid dynamics, typical application, computational mechanics, molecular dynamics, artificial intelligence, in-house or other open source codes that you may have. The list is big, but this is typically what you use the cluster for nowadays. Right. So coming to the skills that are required for HPC usage, this is a very important slide. You definitely need to have some understanding of Unix, because the clusters are based on Unix based operating systems. So Linux is typically what we use. So one needs to know Unix commands and be comfortable with that. So if you're comfortable with it, well and good. If you're not, then get used to it. Okay. So spend some quality time. We'll spend some time today to go through some basic Linux commands, but do spend that time. If you start working on a new experimental setup, you spend a lot of time understanding how the setup is structured, designed, and what are the basic equipment, and the try to understand the behavior of the equipment, and understand the overall setup. So there's a lot of time that goes into understanding an experimental setup. So the same time or a similar amount of time should go into understanding some basic of cluster usage as well. Okay, so Unix is very important. Unix commands and scripting. Nowadays, some Python is also useful, because most of the scripting, so once you have results, you'll want to post process them, or want to write scripts for processing data, for pre-processing, to send it to your code. So a lot of Python is being used. New open source projects will use it. Even old ones have started having Python based wrappers in their software. So it's worth spending some time on learning some basic Python skills, which will help you a lot if your job is to do computations in the long run, or in your PhD or undergraduate or postgraduate projects. It's good to spend some time on learning how to install software from source. So if you're using open source codes, then the providers will give you some sort of code available on GitHub as repository. Then you have to compile the code and install it. So it's worth understanding those standard processes that go into installing software from source code. And then you can do it yourself on your working directory if you want. Then you will not have to depend on the administrators for installing software for you, which in most cases they'll not end up doing anyways. Understanding the code that you're using. So this is a more advanced features. If you really want to spend some time on understanding this open source code that you are using, unless you have developed your own code, then it's okay. And then contribute to the open source community. So you would want to make certain minor modifications, but in terms of the overall output, that will help you test new models, mathematical models you may have implemented in the code. So it's worth doing that, testing it using the HPC cluster here, setting up standard test cases, and then pushing the branch into the master on your GitHub repository wherever the source code is available. So understanding the code is also very useful. It helps you understand whether the problems that you're facing are because of the cluster, which in most cases, if the code runs, it's okay, or because of some standard input that you have given to the code, or is it because of the behavior of the code the way it's written. If you want to extend the boundaries of the code, then it's worth understanding it before you run it. Otherwise, you feel very frustrated because you don't know what's happening with the results. Typically, the type of users you will see in of HPC will be ranging from developers who write their own code to open source code users who will be either using the code as it is or making minor modification, to people who use commercial codes like ANSYS, Abacus, and so on. Okay, so we HPC administrator we discourage the use of commercial codes because they have licensing issues. Some licensing servers have to be connected to. So sometimes you'll say that HPC cannot connect to licensing server. The server has problems with the maximum number of users reached and so on. So if you're towards the beginning of your research, of 5 years of quality research that you plan to do, it is, believe me, it's worth it spending 6 months to figure out if open source alternatives are available to the commercial code that you plan to use. If it's a BTech project only for 6 months, your supervisor is only comfortable with commercial code, then it's okay. I mean, no problem. But if it's a long-term research that you plan to do, then it's worth figuring out alternatives which may actually make your life much easier in the long run. Okay. Lastly, as I said earlier, that you will feel more fulfilled. You will have a better experience overall with the HPC facility if you have these above skills. So it's worth investing every minute that you do in improving your understanding of basic ideas. Right. So we are now ready to go into the discussion on Linux essentials. So we'll take a short break of a couple of minutes to get a drink. And in the meantime, if anybody has questions, please raise your hand. I'll also get a glass of water and then we'll discuss those. Right. Any questions from the first section of the discussion on HPC basics? So this one's going to be hands-on. Right, Linux essentials. So the reason we need to understand about the basics of Linux is because it helps us interface between our local machine and the cluster to communicate, send jobs, open viewing files or transferring files. With Linux, you can also analyze progress of your code. So once you send a job, you'll want to analyze how well things are going. You can do that as well. You can post-process data. So if you would want to do some computation on post-processing, you can do that as well as a compute job by itself. You can also just print out some stuff. So that is allowed. I mean, if you want to print out the contents of a file on a screen, that is allowed on the head node. That's okay. If you would want to automate jobs, so let's say I want to run 10 serial jobs, one after the other, and I don't want to do it at the same time, but I would want to do it serially in the sense of sending jobs. I can write a script that can, from a PBS script, it can scheduler script, it can run one job after the other. So there will be some sort of a loop that I can do on using Linux shell scripting. Troubleshooting. So if things do not go as expected, then to figure out what's gone wrong, whether it's to do with my code or to do with the cluster operations and so on, you can do some sort of troubleshooting on the cluster. And of course, installing new software using Singularity containers, that also can be done through, or launching jobs, that can also be done through Linux. Logging onto the cluster and doing stuff. So you need to know some basic Linux commands to do that. What we'll do now is we'll do a hands-on. So I'll tell you what we'll discuss, so that if that is something that interests you, you can stay. Otherwise, you can join back after half an hour or so. So we'll start with some basic Linux shell commands, going from listing to changing directory, some stuff about modifying, editing files, some basic Linux stuff, wildcards, and so on. We'll talk about SSH, SCP. So these are the basic ideas we'll talk about. The advanced ones will be to find files using the find command. Grepping is a very powerful. It's a very powerful Linux command to search into the files, the content of the file. Then we'll figure out how to redirect output from standard output to files. We'll talk about sorting data on Linux shell, head and tail commands, piping, again, which is very powerful use of shell. And towards the end, we'll do I'll basically give you one demo of a bash script. And towards the very end, we will do an exercise where we'll try to use all of these ideas into one complex problem. Right, so let's start. I'll unshare this screen and share my full screen so that we can start working on it. So you should be able to see my screen now, the way I see it.
Yes, sir.
Right. So this is my shell terminal. Can you see my terminal now?
Yes, sir.
Perfect. Thank you very much. So let's start. Let's start with a simple ls. So ls will tell me what stuff is available on the screen in the current folder. So what happens is, if I do a pwd command, which is a short form of for present working directory, so it tells you where I am. Okay, so I am in this directory called /home/kesser. So that's the directory we are in. I can change my directory using cd. So cd is for change directory. Let's make it full screen. Right. So cd is for change directory, and then I can go to any directory I want. So the way I can specify the path of a directory is either relative or absolute. Okay, so relative is related to the current directory. So there's a directory called, so let's do an ls first, and that lists all the possible sub files and directories of the current directory I'm in. Okay, so this is the complete list of directories I have in the current directory. Files and directories. So the blue ones are directories, and the non-blue ones are files. So I can go to desktop. So desktop is a directory in the current. Well, actually, it's much easier if I do an ls -F. That will clearly identify which one's a directory and which one's a file. So the one that has a slash after it is a directory. So I can see desktop is a directory. So I can do cd, which is for change directory, and then I can go to desktop. Okay. When I press enter, that now you can see that I'm in desktop. So I can do a pwd, which is present working directory. So that tells me that I'm in the directory called desktop, right? So now I can list again ls, and that tells me all the files available on this. I can do an ls minus f. That tells me which ones are directory with a slash, which ones are file. I can do a ls minus l. So that will tell me what it will list the directories with details of them. So it tells me first that what are the user access. Okay, I will not go into details here. Who is the owner of the file? What is the group that we are in? The size of the file, the day it was last modified, and then the name of the directory, name of the file or directory, whatever it is. Okay, so this is called the ls command, which is for listing the details of contents of any directory. There is a very useful command called manual, man. Okay, so man, what it does is it's a manual command, and I can do a minus. I can do a manual ls. So that gives us all the options available in the list command. So we'll go through a couple of them, but you can read all of them if you want. So minus small a stands for all. So it shows you everything. There are some hidden files also available which are superseded with a dot. So those hidden files typically are not shown, but if you do a minus a, they'll be displayed as well. So let's keep moving. I showed you the minus capital F. It classifies based on indicators like slash to differentiate between directories and files. So in Linux, everything is like a file. But if you want to differentiate them, then you can use a minus capital F classifier. Okay, you can have a minus H. It's called human readable. So if you, as you saw earlier, that the size of the file was displayed in bytes. So it's very difficult to differentiate between bytes and kilobytes and megabytes, the big numbers. If you put a minus small h, it gives you things in human readable format. So rather than saying 1000000, it will show 100 kilobyte or 1 megabyte and something like that. Okay. So there are many commands. I'll go through them. So I created a folder called test123 on the screen, which has some standard files in it. So let's do a clear command, which clears the shell in front of me. And then what happens is, as you go further deeper and deeper into the folder structure, this keeps whatever's before $. It shows you the present working directory. But I would want to save some space. So there's something called environment variable. Okay, so it's called ps1. So ps1 can be set to anything. So let me set it to a $space. So when I do that, what happens is I don't see a long list of pwd. If I want to see it, I can write pwd myself, and then I clear my screen. So it becomes much more neater in this case. Right, so let's do an ls. That's how things look. If I do an ls minus a, then probably it shows you some dots as well. So there's no hidden file here, so no problem. Then I do an ls minus f. So this folder, which was a directory, has a slash towards the end of it. I do an ls minus l. So that lists in detail about the contents of the file. If I do, I can have multiple options written one after the other. So I can do a minus l with an f. So now you see that it lists and the folder structure is superseded with a slash. I can do something else. I can do minus lfh. H is human readable. So now if you see the sizes, they are displayed in bytes. If I do minus h, then you can see that now this one 4000 becomes 4.0 kilobytes. If you have megabytes, then it becomes m, or gigabytes is g. So it's much easier to understand the sizes rather than reading the number of zeros or number of digits in a size. And feel free to stop me if there's any question that you have. Okay, there's another command. Sometimes we would want to sort the files based on the last time they were modified. I want to see the latest hundreds of files in a folder. So I can do an ls minus l and then do a t. So t will sort them based on the time they were modified. So you can see that on the top I have the file that was modified the last, and on the bottom I have the file that was modified the first. Okay, all on December 5 yesterday. So I can do I would want to flip reverse the order, so I can do a minus r here with it, so that should reverse the order. So now I see the earliest one created first and the latest one created last. Okay, so these are some standard ls commands that typically you will end up using while working on the cluster. There's also one which allows you to sort files based on their size. Extremely useful, because you'll want to see in a folder how what are the biggest files that you have in a given folder. So for that, what I do is, by the way, I use the up and down arrow keys to go to previous or the next command. So if I keep doing up, it takes me to the previous commands I have used. It's a very useful feature. If I do an ls minus l to list the files, and this time I do, I think the command's called capital S. Let's see what happens. Now what you see is minus capital S is used for sorting based on size, this S. Okay, so now we see the biggest file, it goes to the top, and the smallest one goes to the bottom. So I can reverse the order by putting in a small r here. So then it reverses the order. It puts the biggest one at the bottom and the smallest one at the top. Okay. Again, you can go to the manual of list by writing MA and LS and then see all the options that are available to understand. Right. So that was the ls command. There's nothing else I can think of. Well, there is a help. So you can always, any command that you have typically will have a help. You can approach using help. If you do that, it will give you all the help available on that command. So it's worth reading that. It's also a command called ---- version that typically is available in all the software on the Linux commands. So that tells you, let's clear the screen and type it again. That tells you that what version of the software you're accessing. Sometimes you have multiple versions installed on the machine, so you get confused which one you're accessing. So you can always do ---- version. There's also a which command. If I do that, it tells me this ls actually is the ls that is installed in the folder called /user/bin/ls. Okay. So as I said, you can always access files by their local or their you can access them by their local or by their global path. So the global path, for example, I can access a file by cd/root. Permission denied, of course. cd/home. If I do that, then I am in the folder home. So I can do an ls -l. It tells me that there are two users or two folders actually here in this home directory. So I can reach folders from their absolute path, which is /home/cache. So that takes me to the folder, or I can go to the folder, for example, documents directly like this. So that if I don't put a / in the beginning, that basically means a relative path related to the directory I am in currently. You can see that. If you do a simple cd, that takes you to the home of the user you are. So you can try who am I if you're confused now that you don't have anything before the $prompt. If you do that, then it tells you what the username is. Simply a cd will go to the current home directory. You can also do a cd-, that takes you to the previous folder. In this case, let's say I was in desktop, and now I realize that no, I want to go back to the previous folder, but I forgot the complete path of that. So I can do cd-, and that again takes me to the previous folder. So minus is for the previous folder I was in. You can swap between the last two folders. Right? Any questions on that? Good. In Linux shell, we tend to use autocomplete a lot. So if I do a -ls, let's do it with f. So let's say I would want to open this paper that we written, ijmf underscore paper underscore num underscore gb.pdf. Okay, either I can copy and paste, but I don't want to do that. So I will do cd. I know it starts from I, so I put an I and then I put a tab. That tells me there is only one folder options that are available. Let's say I want to actually open it. So there's a command called vim. That's an editor, text-based editor. And then I'd say ij and press a tab. Nothing happens. I press a tab again. It tells me that all the files which start with ij are these. So I want to open, let's say, the first one. So I write mf underscore and press a tab again. Paper here. Now I press a tab again. There's a problem. I think I've changed my folder. That's the problem. I want to open this file, IJMF paper. Try to use a different editor. It's some problem. Usually it will.
I think it's IJFM instead of MF.
Okay. Thank you. See, typo. Right. So well, it works. Still works. So if I do that and press a tab, it automatically completes it, and then I press an enter, and then it shows this. It's a PDF, so it won't open in the text editor. Right. The other thing is dot and double dot. So if I do an ls with a -a command, then what happens is, let's go to the test folder. It's much easier to work with. If I do an ls -l, it shows me this. But if I do an ls with a -l and a, then it gives me this dot and double dot. Okay, so dot is for the current directory and double dot is for the directory above me. So if I want to go one directory above, then I can do cd with a double dot, and that takes me to the parent directory of the current folder. So this becomes desktop. I was in test, which was this one. Okay. Right. So that's pretty much it for the very basic list commands. Any questions on this? So mostly I will end up using list for sorting the files based on their size and on their modifying time. That becomes very useful. By the way, there's a command called head and tail. They're also very useful. So let's say I do an ls -l. It lists all the files available here, but I would only want to see the top 3 files in terms of size. So what I do is I do an ls -l, but now I want to sort them based on their size. So I do a capital S. It shows me this. Now I want to reverse the order. I do this. Okay, so at the bottom I have a certain, well, you have a folder as well, but that's okay. So let's say we have a couple of them. I want to see the top 3 in terms of size. So what I do is whatever's printed here, I want to see the last 3 lines of it. That's typically what I want, right? So I use the same command, but this time I pipe it to head with a tail with a -3. So that gives me the last 3 lines of the above output. I'll tell you what this output means. What we have done is we have printed all the files, sorting them in reverse order based on size, and then whatever I got, so pipe is basically feeding that to another command, and then I fed it to another command called tail. So tail, what it does is it takes the tail, basically the last, I do a -3, so last 3 lines of whatever was sent to the tail command through a pipe. So pipe is to send information. So all the lines were sent to piped to tail command, and then tail command extracted the last 3 lines using the -3 command. So we have these 3. If I had done a -1, I would have got only the largest one out of these. Okay, very, very useful for cluster management as well. If you want to make directories, you can use the mkdir, mkdir. Any basic Linux tutorial will have these. So I want to make a directory called test underscore today. If I do an ls -lf, so that tells me that now I have another directory called test underscore today. It's empty as of now. So if I do a cd to test today, then I can see that there is nothing here. Okay, it's empty. Okay. Now, if I want to create a text file using an editor, so there's an editor called Vim, or you can even use Nano. I tend to use Vim. It's installed on the cluster as well. So let's say Vim, I want to create a new file, a new text file.txt. That creates a new text file. It takes me to a new screen of Vim editor. I can write I, that opens insert. So you can read about Vim by yourself. And then I say that hello. Okay, so I can do, there's a :W for save and :Q for quit. Again, we don't need to worry about this. So that has created a new file. If I want to print the output of the file on the screen, I can use the cat command, and then I can write the name of the file, which is new test file.txt, press enter. So it prints the output of the file on the screen. That's for using the cat command. You can also use the nano editor, nano, and then write the name of the file. Sorry. So that opens the file in a different text editor. So this is much more comfortable to use, and then I can type something, and then the commands actually are available here, basic ones. So exit is Control X. So let's do a Control X. It says save modified buffer, Y for yes, file name the same as earlier, so it's already printed. Press enter. Now if I do a cat new test file.txt, sorry, it has to be small. Sorry, yeah. So now you can see that it prints the contents of the updated file. Okay. Useful commands, nano, vim, and cat. A very useful command is copy. Sometimes you want to copy files from one folder to the other. So let's say, let's go up a directory. So now I have, I would want to create a copy of the file called, let's say, out.e. Okay, so it's called copy cp, command for copy, out.e. That is the file you want to copy, and I want to copy it into a file. I mean, of course, a new name. So out underscore backup.e. If I do an ls now you can see that we have an out underscore backup, which is exact copy of out.e, and you can see that it's basically having the same size, 140 bytes. I can do a cat of out underscore backup.e, and it gives me some output which was available in out.e as well. Okay, so cp is for copy. I can also move files. So if I want to move the out underscore backup, into the folder test underscore today, I want to move this file, drag and drop this into test underscore today. So I can do an mv out underscore backup.e, and where do I want to copy? I want to copy it into the folder test underscore today. Okay, that's in the current folder, so relative path. You don't need to put the slash, but it's good to do it so that you're clear it's a directory, and then press enter. If I do an ls -l now, I'll not see the out underscore backup here because it's moved to the test today. So let's do test, sorry, cd test underscore today, ls minus l, and now you can see that that's out underscore backup has been moved into this folder test today. Okay. The other one is the remove command and the delete command. Very dangerous to work with, but required. If I want to delete this file out underscore backup.e, I'll do an rm, it's for remove, rm is for deleting, remove, and then I say out underscore backup.e, I press enter. Does not ask me anything, just deletes. Okay, in some cases it will ask you and then you have to say yes, but I have switched that off on my terminal because I'm confident I use the remove command without making errors. Then if I do an ls minus l, out underscore backup is gone. There's no recycle bin here. It does not go to recycle bin. It just deletes it from the hard drive. So be very careful before using the rm or the remove command. Double check, triple check where you are, what you're deleting, and then do it. Okay. Right. Sometimes I remember that 10 days ago I used a command which was a very long command. I remember only a few words of it. So I can do a recursive search. I can do a control R. So if I do that, it does a reverse search. And I remember the command was called MV. So I do an MV. As soon as I type MV, it brings the last command that used MV in it. I can keep pressing Control R and then it will keep printing on the screen in the reverse order where the MV command was used. So it will give us all sort of commands that had MV in it. Very, very, very powerful. It basically, there's a bash history available on your home directory that has the history of all the commands that you have used till now. So it accesses that and does some search there. But on the terminal, it can be quite useful for you. So Control R for reverse search of text in previous commands that you have typed on the terminal. Okay. Any questions? Very good. Next is wildcards. Let's talk about that a bit as well. So wildcards are, well, as the name suggests, they are wildcards. So let's go up a bit. We have some stuff to work with. So let's say in my folder structure, I want to print out. I remember that the file name was starting with file, but then after that it had one digit or one more character. But I don't know what it was. I put a question mark and then I press an enter. So it tells me everything. So it puts anything in front in place of this question mark, and it gives me all the files which had exactly one character after the letter E in file. So file 1, file 2, and file 3 fit this criteria. So it lists all these. So I can still use minus L with list. So it prints them and sort them using size and so on. So that all works. In this case, they're all empty files basically. There's nothing inside them. So there's all 0 bytes. Okay. This is wildcard question mark that is used to replace any one character. Question mark can be in the middle of this as well. So if it was, I remember it was FIL, then there was some letter, then there was 1 or some character and then 1. So the only file that fits this criteria is file 1. Okay, so this is a wildcard. The other wildcard is star. If I do this, then star can be of any size. So if I do enter now, it prints everything that had anything after file. So it starts with file and then anything. File underscore hello, file underscore new, file 1, file 1, 2, file 2, and file 3. Okay. It can even have a star in the beginning. So there was nothing which had anything before file. Let's see if we can try this. Okay, so let's try star, ILE star. Okay. So all the ones which had file fit this criteria. If I do a star, anything that prints everything, because star stands for anything. So basically that's, if you do an ls star, then basically that's everything. Okay. So star and question mark are very useful wildcards which can help you list out files if you don't remember exact name, but you do remember that it had a long name with file in it. So star file star will help. Okay. There's an echo command. So let's say here, if I do an echo before this, basically what's happening is, before actually the ls command is run, it replaces the star, it completes the star with whatever fits the star. Let's just make it much clearer. So let's say star file star. We don't need sorting here, we just need listing. So if I do this, so what happens is, it does not run the command. Its echo is simply to echo, it's to print on the screen, standard output screen. It echoes thing, it does not run it. So it tells me that if I do this, what is actually executed in the terminal. So terminal executes ls minus l followed by all these names, because star first expands to names and then it runs the command. Okay, so echo is simply to print stuff on the screen anyways. So if I do an echo and then say hello as a string, it prints hello. Remember, we had this ps1 variable that we set to change the dollar sign, change the terminal sign. So that was a variable. Okay, it's a terminal variable. So if I do an echo dollar ps1, actually prints that dollar space. Okay, that was what ps1 contains. So these are called terminal variables, which can be set as any value. So I can create variables and use them as, so let's say I create a variable called var that is equal to 100, and if I do an echo dollar var, that will print the value of this, which is 100. Okay, so you can also work with variables in the shell. Sometimes I would want rather than sorry, this question.
Yes, sir. Yes, sir. Like changing the sir values in terminal, like how it will help.
So when you install software, sometimes it will ask you to modify the terminal variables.
Okay.
Okay, so they are basically, if you are installing a software, let's say, and that software requires some sort of dependence in some other software. So let's say you're installing software, it requires ParaView to be installed. Okay, so it's already installed ParaView somewhere else. So you have to give the path of that ParaView software as a terminal variable. Okay, so it will just say that before executing the installation command, can you please set the path of this installed software ParaView in this terminal variable.
Yes,
So
sir.
you
Got
can do
it.
that. Any other questions? Right. So these terminal variables or environment variables, they are very useful, and you will figure out when you need them. Okay. But they are in most cases, if you're working with bash or some sort of installation of software, it becomes very useful. Quick access, basically. Right. So moving on. Sometimes I want to forward the output rather than printing the output of ls minus l on the screen. Let's say, well, I do that a lot. I try to um, run a command called du, disk usage. Okay, so that is telling me everything that's inside a folder. Okay, du with a -h. So that if I think that somebody has created very large files, I just basically want to figure out what is the usage of each folder on the cluster, and figure out what are the top 5 users of the directory, working directory in the cluster. So I use the du command. But I don't want to print it on the screen, because I run the command, I switch off the terminal, I go back home from my office, and then tomorrow the command will take 2 to 3 days to run. It's accessing the complete folder structure, and then after 3 days I want to see the result. So the result should go into a file. So I can redirect the output of any command from screen to a file. So using this greater than sign. So if I do a greater than, and then let's say the output should go into a file called usage.txt. You don't see anything on the screen, but if I do an ls-l, you will see that there is a file called usage.txt. So the output of the command, which was which was du -h, has gone into usage.txt. So I can do a cat usage.txt, and then I see that the content is there in this file. If I do it again, so the file will get replaced. But let's say no, I did it for a few folders. Now I want to do for the other folders. So rather than replacing the usage.txt, I want to append it. So I can do a double greater than. And now if I do a cat usage.txt, now you see that the previous stuff remains, and it appended the output to the same file. Now I have both the content from this redirection and the previous redirection in the usage.txt. So this is also very useful for people who use the cluster. Okay. The other is the SSH command. Well, everybody uses that to connect to the cluster. Let's say I want to connect. So my username is Gaurav at 10.8.1.19. So this is the command I use. Press enter. It asks me the password. So I enter my cluster password, and then it takes me to the cluster. You can see that it says at N199, that's the head node of the cluster. And it also tells me when was the last login. That was yesterday at 10:53 p.m. from my home machine. So now I can do an ls-l, and I see stuff which is there on my cluster. I can type an exit and come out of the SSH command, and then I am back in my home desktop. Okay. So this is SSH command. The other one is SCP, secure copy. I want to move files between the cluster and my current folder. So let's say I would want to copy this file called file_hello. Let's print the content of this. It has some stuff in it. So I want to copy this file to the cluster home directory, and then I do something with it. So for that, I'll have to use an SCP, not CP, a secure copy, and then the file name. So right now I am in my current home directory. So this is relative to the current path. It's file_hello. And then where do I want to copy it to? To the cluster. So the cluster requires login. I want to copy it here. Colon means home directory. I want to copy to the home directory of my cluster. If you don't put a colon, it actually takes you to the root directory of the cluster, which you will not have access to anyways. So put a colon after this. So that basically says that secure copy this file_hello in the current folder to the cluster 10.8.1.19, whose username is bgaurav, and into the home directory of bgaurav. Press and enter. Took some time. Now it's asking me the password for the cluster. So let's enter that. And then it has successfully transferred 100% of the file. in 26, what that is, total kilobytes, I think. And then at the rate of 12.3 kilobytes per second is almost no time. It will give you some progress indicator if the file is copying gradually. You can see how many files have been copied and so on. So now I can go using the top arrow command, try to log into the cluster again using SSH. Let's see if that file underscore hello is here. It's here. And it says it was created on December 6 at 12:32. So basically this file was copied on this time. So that's the latest modification time. I can actually do a cat file underscore hello. It has the same content that it had when it started from my home desktop. Okay, so this was very effective. You can see that now we are actually using the cat command on the cluster rather than on our local machine. Use an exit command and come back to the home desktop. Right, so this was SSH and SCP commands. Many people tend to use other transfer clients. That is completely okay. Graphics-based clients or Nautilus can also be used for logging to the cluster. But I'll recommend you use the terminal because then you have better control over what you're sending. Sometimes if you use a graphic-based, you just drag and drop something from here to here by mistake by pressing a button on the mouse, things get misplaced. They're just gone sometimes. Okay. It takes time to get used to it, but it's very, very robust in terms of not doing things that you don't expect them to do. Okay. Right. Any questions? Okay. So let's say I want to find a file which has a name called usage.txt. Now here I can just visually look into it, but let's say I had a big structure. I don't want to waste time on ls and figuring out. I just want to find it. So I use the find command. I simply say find, and where do I want to find it? I want to find it in the current directory where I am in. So current means dot. So dot stands for the current path. I remember the name of the file. That was usage.txt. Enter. So it tells me that yes, ./usage.txt is available. There's a file. Okay. That was very trivial. I mean, it's there. Yes. I don't remember the complete name. I just remember it started with usage. There's nothing. But if I use a wildcard, yes, there's a file called usage.txt in the current directory. So that again is very. I could have used the ls command anyways. But let's say in the test today folder, I have a new test file.txt. Let's go up again. I'm in this current folder. So your folder can have another folder which can have another folder and so on. Recursively, there can be a whole tree structure. So let's say I want to find a file in the current folder which has a name called new underscore test underscore file.txt. That's a name. You can also search recursively. So it was able to find the file new test file.txt. That would not have been possible with an ls. Let's say this file was somewhere there in the computer. So I can actually go up a folder. I can go to my home. I can go to root. I can search files if it's my local machine. Okay, so find is used to find files which have a certain name or their name has that particular list of characters. So you can use wildcards to find them. It's like find button in a search button in Windows, something like that, but a text based and very powerful. You can do further stuff with it as well. For example, if I want to delete it or move it, I can do this and then I can use some redirection of output and move it as well. But I won't do it right now in this basic training. Okay, so find was one command. Now the other command is called grep. Grep, grep. This is even more powerful. So this, let's see what is there. Okay, so there is a word called hello with a capital H in it. Okay, so let's use grep command. Now I want to search all files which have the word hello written in them as a text. Let's start with this. I was in test today. It has lots of files. I don't know what's there inside it. I don't have the time to go into it. But now I do a grep hello with a star. It tells me that it does not print. Okay, I think minus L will, yeah. So if I do a minus L, it tells us the name of the file where this word hello was found. And if I do simply grep, it tells me where what was the line that had hello in it. There are multiple things you can do with grep command. You can combine the file name and so on. Sometimes it will give you the file name and then the content and so on. So many things are possible. So this was grepping. It's basically searching into the file. Now let's say I was up one directory and I had files in my directory, I had folders in my directory, I have folders in my directory which have files in them. So if I do a grep now, I want to grep into all the files, all the folders, all the files inside the folders in the current directory and so on. So if I do a hello, which actually I did earlier, nothing is there. It just tells that something is a directory and so on. But if I do a grep with a recursive search, is minus R says you can go into the folders as well. It takes time, but you are allowed. So if I allow that, then it was able to search all the folders and find this file new test file.txt which has this text in it. Okay. Very useful. I was able to find out the file in the current folder structure which has this word hello in it. Okay, so very powerful command in Linux. Any questions? Right. Okay, head and tail I have discussed with you. Okay, I also briefly talked about the piping, redirecting output. So let's do a complex exercise. So what I want to do is I would want to move the largest file in the current folder into a new folder. Let's say I am in this folder and I have lots of files here, some directories as well. I want to find the largest file, not the folder, the largest file. So if I do a ls minus L with an F, it helps us differentiate between the files and the folder. I also want to sort them. I use a capital S. So now what it does is it sorts them based on size. I would want to keep the largest one at the bottom. So I put a reverse search. So small r. So it reverses the order. Okay. But I want to find the largest file, not the largest folder. I actually want to pick up this file. So what we can do is, this is where Linux becomes powerful. I can pipe this output to grep, and grep has something called minus V. So let me show you that minus V. So manual of grep, I can do a slash minus V, which basically searches for minus V. Small v. It says invert match. Okay, so inverts the sense of matching. So basically whatever is not matching an expression will be shown. Whatever is matching will not be shown. Okay, let's quit and go back. So this is the command. I would redirect into grep invert match slash. In this output that I have, whichever output has a slash in it, it should not be shown. Everything else should be shown. If I do an enter, now you see that it has removed everything which had a slash in it. Typically, you will not have slash in file names. Don't do that. So that ways, it only shows the output which has files. So this is how you segregate files and folders from an output of an ls file. Okay, so I have been able to successfully find out the files in the ascending order. I want to print only the last line of it, so I can redirect the output again using a pipe and say show me only tail -1. That prints only the last line, which is the largest file. Okay, and this is the file I want to move, but I don't want to now list it. I just want to move it. So I will remove the -l from the list. So what now it does is it prints only the file name. And actually, I now want to work only with the file name. I want to move this into a folder. Let's do that. So let's say MV. I'll not use the file name because I don't know which file is the biggest, going to be the biggest, right? So let's go to this command, put it in brackets, and put a $. Here. Basically, what that does is it says move, and the result of whatever the ls blah 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 command is going to give you, which is basically cat. So this whole thing with a $, will give you a cat. Okay, and then I say move it to the folder called folder. Press enter. Now if I do a cd folder ls -l, we see that the cat file has been moved. Okay, so this was a very complex command structure. It had 3 sub commands. So you list out all the files and folders in ascending order of size, remove all the folders, have only the file names in ascending order of size, take the last name, which is the biggest one, and then you move that largest file to the folder called folder. I think it gives you an understanding of how complex stuff can be done using Linux commands. That was the intent of this discussion. So I think we have gone from very basic to very advanced gradually. Any questions? Right. So let's look at scripting now. You can also make loops. So I have created a script in bash called test script. So let's print the content of that. So this script, what it does is it renames all the files which have a .dat as their extension and makes them .data. For example, you have this file called test_data. So let me rename it again because I had run the script earlier. Test_data. I've renamed this file as test_dat. If I now run this script, so the script is run using the bash command, bash test_script.sh, and I run it. Print something as a part of the script. But now if I do an ls, now you see that this test_dat actually has been renamed as test_data. I can move it back to that. I can actually create a new file, test1.dat. That is just to create a file without any content in it. So I have 2 dat files now, and now I run the bash command. And if I do a test -l, ls -l, I see both of them have been renamed as test. Their dat has converted to data. So their extension has been. Basically, I have accessed multiple files based on some criteria. I have looped through them and run some move command on them. Okay, very interesting stuff. Sometimes you would want to rename all the files in a given folder structure from file whatever they have, and then have _1, 2, 3, and so on. So you can also do that. That is also possible. So let's briefly see what the script does. So it basically runs a for loop. So for file name in start.dat, So start.dat will expand to all the file names which have a .dat at the end. So test1.dat and test.dat to start with. And then what it does is it extracts the name. Only name basically will have the so echo, I did an echo only name. So that printed test1 and test2. So it basically removes the .dat at the end by using this cut command. The delimiter is dot. So whatever is after including dot and after dot is cut from the text, and that becomes the name of the file. And then I rename the old file name to its name dot data, and that's the loop. Okay. Again, this is just to tell you that you can do these things. You can always go to the Google search and search for standard scripts and then modify them based on your requirement. Nobody writes scripts from scratch nowadays because there's so much available on the internet. And when you create your own scripts, you save them in your folder on OneDrive or somewhere. So you can always start from scripts that you have written in the past because you have understanding of those scripts in detail. Okay. So that concludes the section on Linux Essentials. So I hope that you've been able to extract some useful Linux skills out of this session. Any questions? No questions? Well, if there's nothing, then we can go back to our slides. So next is job submission. I think we can take a short break, 2 minutes, and then come back and talk about job submission. So we'll start. Job submission. That's something, that's the first thing one has to do after they get an account, start to run jobs on the cluster. Firstly, I'd say it's very straightforward process. So let's start with checking out the HPC website on how to submit jobs. It's on the website. There is useful scripts available here. So what I want to do right now is I simply want to test how to submit jobs. So for that, I'll pick up code which is quick code, in the sense of how it runs quickly, and it's a serial code. It does not require multiple cores. Keep things simple. So I have this script called serial script. So let's pick that. That's the simplest one. So what I do is I simply copy the content. You can actually open it into a file, but that's okay. So I copy the content of it and I log into the cluster. Actually, it's better if I share my screen with you. Right. Okay. So I do an SSH. I've logged into the cluster now, and what I want to do is I would want to create a script. So I just copied content from the HPC website. So let's do an ls-l. Lots of stuff available here. So let's clear the screen and create a folder, mkdir, say demo December 6, 2021. I can cd into this demo December 6, 2021. Let's check present working directory. I'm in this folder, and then I create a bash script. So I'll say nano, and the script name is serial underscore submit.sh. That's the name I've given to it. It's my choice. And then I can do simply using my mouse, I can do a control. Oops, there's no paste here. Try copying it again. Let's control C. So now I can paste it. Simply copied and pasted stuff. So let's modify it. You can leave stuff as it is to start with. But I have to modify this command, which is /a.out, because that's running a file /a.out. So what I'll do is I'll simply run a ls command. Okay, it's the most trivial I can have. I can do I can print a pwd command. That's allowed. I mean, I can run a pwd command, and that actually runs on the compute node. Or let's make it slightly modified. I run a pwd command, and whatever the output is, I redirect to a file called file, or well, let's do append file underscore pwd.txt. There's nothing else I've changed. Let's do a control X, exit. Yes, save it in the same name. I can do a cat serial submit, and it prints all the stuff. Okay, So this is my first script has been created, and I am running simply a dummy command to test it. Very good. So let's run it now. So for that, let's go back to the website, and it says submitting job. How to submit a job? Okay. So it says jobs on the HPC cluster must be submitted using the PBS script that we have just created. Under no circumstances, in bold, should you execute your job directly on the head node or any compute node. Okay. You should not do it directly. You should do it using the PBS commands available. So that you should allow the scheduler to allow scheduling the jobs rather than running it on the head node directly or going to the compute node and running directly. Again, we allow you to go to the compute node also just to check if things are running fine and so on. But don't run it through the directly, run it through script. Okay, so there's a command called qsub and then script. This is to submit a job to the default queue. But right now, simply copied the stuff, but I'll talk about this queue here. The queue is called serial. So let's run it, qsub, and then the script. And I press enter. It says it has given some ID to my job. It's worth noting it. So I noted down on a piece of paper. (280,486), and the rest is standard. And then I don't know what's happening. Okay, I can do an ls and see if something has happened. Something has happened, right? I can see a file underscore pwd has been created. Let's print it. It was able to do a pwd and it printed the output. And this all happened on the cluster because I submitted it using the qsub command through a script. Okay, so it ran successfully. Very good. Now there's a qstat command with a -a. So what it does is it tells me that a job ID called 280,486 with the username bgaurav was run on a queue called serial. The job name was my serial job. That actually was specified in the script. You asked for a total of 10 hours and the status of the job is C, which is complete. So all these things you can search on the internet, and we also provide the PBS documentation, so you can read about it. What is the meaning of C? What is the meaning of R? What is the meaning of Q? But it's obvious. Q is Q. In Q, it's waiting. R is running, and C is completed. Okay, so this is what it is. Typically, what happens is it's a very nice situation here. It also says you have new mail in vars pool mail bgaurav. Typically, what will happen is you will also get an output and an error file. If there's an error, it will go to an .e file, and all the output on the standard screen goes to a .o file. But they have not come, so there is some problem. It does tell me that you have a new mail in this, but the file, the code ran successfully because I have this file created. So I can actually go to this folder. I can literally copy it and paste it here and do a nano. It opens the file and I can go to the bottom. There's lots of stuff in it. Then I can try to read the last few lines. So it says it's a mail basically that delivered from admin on December 6, 12:59. So we need to have the patience to read all these things. Okay, and that is what I'm impressing upon you, that patiently you have to read these things and understand what's happening here. So there was a mail generated at 12:59. It was sent to me. The subject was regarding this job 280,486, and that is exactly, I noted that down. So that's my job. Okay. So what is the content? So it says an error has occurred processing your job. See below. Post job file processing error. So it basically means that the job ran successfully, but after that there's some file processing involved that has some problem. And the problem was that it was unable to copy the file, this blah 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 .ou, which is the output file, to my current folder with this name. Okay. So there is actually some problem in communication between nodes which created this issue. So this issue is an issue which you as a user cannot solve. It has to be solved by the administrator. So there was some problem copying a file. So what happens is when the job is run, the output file is copied from some standard scheduler folder to your folder, but that could not happen. Okay, this is the whole thing. And then host key verification failed. Okay, so this was some key verification issue. I had actually modified my SSH keys in my current folder that created the issue, but that can be sorted out with the help of an admin, or if you are an expert Linux user, you can do it yourself. But it's not, that's not the end of it. It says that since I could not copy these things, I have retained the output in this folder, okay, with this name. So this complete path is given to you, you can copy it, but that is on the host. The host was where the job was sent. Okay, the host was N130. So what happened was, if you remember, the head node, which is N199 that you were interacting with, when you ran the script, it sent the job to a compute node which has an ID called N130. The job ran there, and after finishing, it was trying to copy the output and the error files from that N130 to your file system, but it could not do it for some verification reasons. It could not copy the file, so it retained the file. So basically, this is the complete path of the file that is there. So at this stage, what I will do is, as a user, I will SSH to N130. Okay, that is allowed. We have given you that access to log into the compute nodes directly. I am there. Okay, so now I can do a cat and then the complete path that I had copied from there, where the result has been retained, and press enter. So the output of that file was running on N130. So it tells us where the code is running, and program output again, there's nothing here. That is basically the text that was there in this file, and it could not copy this file for some verification reasons, and it retained the output there. So there was no need to panic. If you read the output carefully, then everything is there. Your results were generated, they were copied to your working directory or the home, wherever you had them, wherever you wanted them, and whatever could not be copied, basically the output file and error files are the ones that cause an issue. They were already available, so I can simply copy it, or I can do a CP and this whole thing, and I can do it to my home, which is direct accessed by tilde. And then what folder did we create? Demo. I copy it. That file has been copied to my folder now. I did it manually, and then I can do an exit. So that takes me back to my head node, because I shouldn't be doing much stuff on the compute node anyways, and then do an ls, and I can see that the output file is here. So I can do a cat 280, whatever this is, and it's there. Okay, the cluster has been created in such a way so it's almost fail safe. I mean, if things cannot happen because of some reason, then we will give you, that's the reason we've given you SSH access to the nodes and so on, so that in case of these issues, you can sort it out yourself. Now, in an ideal situation, if you are paying a lot of money to managing cluster and running jobs and so on, then they will have dedicated staff available who will listen to each and every of your requests and try to make the cluster as streamlined as possible. But typical university clusters are not developed in that sense. But with a little bit of knowledge and experience, everything works fine. So your ultimate aim is to run compute jobs which will run fine. So we've given you all the framework. Sometimes because of it actually this happened because I actually deleted some files in my bash folder myself to create this issue for you. for troubleshooting. Okay, sometimes it happens that we are trying to do something and in SSH folder I deleted some file or something happened on the cluster end, but that's not the end of it. That is what the message is. And if you talk to each other through forums that we'll create, you can actually sort these things out by yourself. And if you Google it, mostly all the stuff is available there, but have the patience to read errors, try to troubleshoot yourself, and you'll figure things out yourself. So is that clear how to send jobs using PBS script? Any questions on that? Okay. Now this command could be anything. Okay. This command could have been replaced by, or I can have multiple ones as well. So Python, and then running some script.py. Call it Python underscore script.py. So all the list of commands that you want to run on the compute node can come here. It can be your own code, one after the other, whatever it is. Okay. So let's try to understand this file, a script file. I mean, you can do it if you go to PBS scheduler documentation, and internet has lots of stuff available. Almost all the clusters will end up using a PBS based scheduling. So the important ones are the queue name. Okay. So hash PBS is where this is a comment and this is a command. So when I do a -q, after that I have to give a queue name. Since my job was serial, I could use a serial queue. If I go back to the website, and show you the list of queues here. So on N199, I have lots of queues. Okay, so if I look at the serial queue, it says that it allows a wall time of 1440 hours. Okay, 1440 hours is the maximum your job can run for. Anything beyond that, it will automatically shut down. So if your job requires typically 1000 hours, then I would happily send it to serial. It has a memory of 190 gigabytes, a lot. It can run a total of 25 jobs. When I actually, this was what was running when I ran this command called qstat -q. Actually, let's do that. So rather than looking at the website, let's close it. Let's run the command. Let's clear it first, and then qstat -q. It will print all the queues available in the cluster at this time. So there's a command called, there's a queue called day. So that basically has a wall time of 24 hours, as the name suggests. There's a queue called week, a wall time of 168 hours, that is 7 days. So on the day queue, you can see that right now only one is running, one job. There's nothing queued because if there were more, then they will run as well, because a total of 8 are allowed. Okay, so I can see, I can run this command and I can see that what is the load on the queue. Well, day queue is almost free, so I can use it. And see, it's vacations are starting, people are going home and so on. So that's the reason it's not very full, the cluster. On the week queue, a total of 40 jobs are available and 11 are running. Nothing is in the queue. Of course, I mean, you can run up to 40. Then on the serial one, 34 are running and the limit is 20. So limit actually means, I think it's limit per user. So different users can run different number of jobs. Total of 34 are running and there's nothing in the queue. Okay. There are some private queues as well which have a priv before them. So people who buy nodes from their projects and so on, they those nodes are typically created using a private queue. So if your supervisor has a node, you can always ask him to send us an email at hpc@iitmandi.ac.in, and we can give you access to that queue as a user. So then you also have access. So then you can send your jobs to private queues. Okay. They're all private queues. There's a queue called infinite. Okay, so basically that is not infinite. It has a total of 720 hours of wall time. Call it infinite, but it's a very large number. Although private ones are extremely large. Okay, that's because there's somebody private. If it's a private node, then it's an exclusive access to someone, so they can run the jobs as long as possible. But for other common queues, we keep the wall time limited so that after 24 hours, the next job in the queue, if there was the jobs in the queues, they will get executed. So everybody gets a fair access to the hardware. There's a queue called low PR as well, which basically has access to private nodes at a low priority access. So what happens is, if I've used all the queues, they're all full, I can use a low PR queue. So low PR will actually go to a private node which is not being used right now. But as soon as the owner of the private node sends a job, your job will get suspended. So it's running things at your own risk. So it's up to you. But if you, to start with, use the serial queue for serial jobs, or day queue for parallel jobs which require 24 hours or less, week queues for jobs which require a week or less, or infinite for jobs which require a lot of time. But infinite queues typically mostly are queued jobs, so they will not execute immediately. Right now the cluster is underloaded, so it's okay. Okay. And I mean, see, if you run something on the day queue, you get only 24 hours access, but things will move very quickly, because after 24 hours, the jobs will stop, the new jobs will start. So if you have a job that requires 3 days to run, what people do is they create checkpoints. So after 1 day of execution, all the results towards the end of the day are stored in a file, and then you start the next execution from that intermediate result. That typically, any code that you write, or any open source code that is parallelized to be used on the cluster, that will have checkpoint files. Okay, so you can always initialize the new run from the output of the previous run, so you continue from there without restarting from time 0. Okay, so that was on queues. Let's go back. I can change this. Okay, so let's try changing it to day. All time, I don't need 10 hours. Actually, I need only 5 minutes. Change it to 5 minutes. Running on, so this basically tells us to which compute node was the job sent to. It's good to have that, because in case you would want to go back to the compute node and figure out if the files are not copied properly or something, so you can always do that. Right. So good. So Python script is one file that I have. I would want to run. Let's create a Python script, a very basic one. So that should work, I think, in Python. And try to print C. Okay, it's I think it will go to Python 2, so that should be okay. If it goes to Python 3, then we'll have to put it as a function. So let's see what happens. I mean, it should do something at least. If it does not run properly, it will have an error. Right. So I have this. I don't need this one, so I can actually remove it. So I can copy it and do an RM. Double check things again if I'm not making any mistakes. So RM and this file name. Okay, good. ls minus l. So I've got file underscore pwd. I don't need this as well, because I would want to figure out if it's generating new file. So I will remove this as well. But rather I can keep it, because I'm appending stuff. I'll figure out if it appends more stuff into it. Okay, good. So I can now do a q sub command and do a serial underscore submit.sh and enter. This time it creates a new ID 280488. Earlier was 486. So basically, somebody else also may have run something. Okay, good. Let's do an ls minus l. Let's do a cat file underscore pwd. Good. So I think it ran because it has concatenated, appended output to the previous ones. It's printed it twice, so it ran. I'm happy now. I can do a q stat for the queue status. It says 280488 has been executed. So C is completed. It ran in day queue, and there is again a mail. Okay, so it could not copy because of the same reason. So that's okay. Let's read the mail. The cat will simply put everything on the screen here, which is okay. So the mail was sent at 118, which is current. It's sent from it's saying N130. So job went to N130 again, and the error was again that it could not copy. So that's okay. I can always copy this. Okay, and then I can SSH to N130 quickly and do a nano and then open the file. Oops. No problem. Okay, sorry. This is output is here. Okay, I was printing the wrong one. So nano. Okay, so this is the output that could not be copied. So the standard output, which was supposed to actually, if you ran the command, Python command or whatever on the screen, it would have done it on the screen. It goes to a file called .o file. So it's running on N130, which is what supposed to was there. And then you remember that 2 plus 3 equal to 5. So 5.0 was actually printed. Okay, so the Python command also ran fine. Good. So I can do an exit now and come back to the head node, which is fine. So see, I don't have control over things. I want to get things done quickly. What I now do is, instead of printing the output of the Python code onto the to this thing, let's go to the Python script. Rather than printing it on the screen, I would rather redirect it to a file. Okay. So well, I won't do it now. You can do it yourself. Okay, I'll open a file and then I'll print it into a file, and then that file will actually get created here. So the only problem this is facing right now is because is to copy the output file from the compute node to the head node. Otherwise, all the files otherwise on the working directory are getting created fine. Okay. Is that clear? This is the most important discussion if for anyone who wants to run stuff on the. So somebody had a question about how do you run commands on cluster. Have I answered that question? You're still there, right? Yeah. You can hear me? Anybody?
Yes, sir.
Yes, yes, sir.
Thank you. Thank you. Is there any question on job submission? Feel free to ask. Right. So thank you very much. So that ends the discussion on job submission. We will break for lunch now, and we'll come back in 1 hour. So I think we should meet at 2:30. That will be a good time. Gives us 1 good hour for lunch, and then we'll continue with the today's training. Yeah. Thank you very much. I'll see you at 2:30.